Okay, thank you for coming. Today I would like to bring to the table a way to integrate printed electronics that's not often discussed even in this forum, and it's about embedding functionalities into composites. And when I say composites, I mean fiber-reinforced plastics. But first, and this being the first time that Tecnalia is presenting this event, just a couple of figures about us. We are a research center, actually the biggest research center in Spain. We are located in the north, in the Basque Country. We are over 1,500 people, and hence we are active in many fields, such as sustainable mobility or energy transition or smart manufacturing. And these activities are aligned, of course, with the SDGs, but most importantly, we are aligned with the priorities of our customers. And a really good measure of that one is that chart you can see there, that it's true that us being a research center, half of our funding comes from, it's a public funding, but at least the other half needs to be from direct contractor from our partners, our partner companies. Those are private contracts. Us in Tecnalia, we all here know what functional printing or printed electronics is. It's all about depositing functional materials only wherever it's necessary. And for us, for Tecnalia, we are convinced that the unique value proposition of all these technologies is being able to integrate functionalities wherever it's necessary or where it was not feasible before. Some of our partners, they come always asking for costs and maybe sustainability, and it's also there, but the main driver is this one. When I say functionalities, I'm thinking about this. Nowadays, sensors is one of the most relevant. Also, when it comes to composite functionalization, we can do temperature sensing, strain sensing, capacitive sensing, and this is applicable to all of the sectors we are active in. Of course, lighting and human-machine interface, it's always there. Maybe not as relevant as sensors when it comes to composites, but it can also be done. And nowadays we are researching strongly in developing the processes, working normally with commercial materials, but developing the processes to be able to substitute the wiring. Because we see that there's a huge potential there to reduce weight, also even reduce costs. Heaters is an already well-known application, and carbon-based, silver-based heaters, they are already well-known, but depending on the way we integrate them, there is always margin for some research. And we envision that in the near future, one of the most relevant applications, one of the most promising ones, will be related to RF applications, meta surfaces, antennas, and also, why not, in the aerospace industry, which is always also demanding weight reductions and compact integration. But why should someone go for a printed alternative when there are already some solutions in the market, for example, for sensors? Again, here we always mention sustainability, cost reduction. Some of our partners, they see that they can, when it comes to strain gauges, for example, they can reduce the cost, maybe not of the gauge itself, which would be competitive, but that will not be the driver to change to this technology, but they see that they can automate the process and be not that much skill dependent of the worker who's applying the gauge. But again, the main interest of going to a printed functionality is that whatever we do is much more adaptable than their rigid counterpart, and it can also better integrate it, and especially when it comes to composite manufacturing, because we have achieved some processes in which we are able to embed those functionalities with absolutely no integrity loss, which is very important here. And we consider that it's so important that in Tecnalia we have defined our strategy based on these integration methods. Besides the composite, which I am going to go more in depth now, we can also print directly the functionalities on 3D surface by mounting some jetting heads on robots. And using those same robots, we are able to manufacture additively polymers with FDM or FFF, and on the go also print the electronics functionalities and even then cover them with some more plastic. I mentioned before the RF applications, that they are some application on one hand, but they also enable even wireless integration of the functionalities, which is also, it is of course a challenge.